In this lesson, we are going to look at solving simple linear equations. First, let's have a look at what are equations. An equation is a statement which two expressions have the same value. For example, 2x plus y, one expression, that equals to 45. Another expression. Another example, 3y equals to 35 plus x. 3y is one expression, and 35 plus x is another expression. So all these examples here are actually equations. At this stage, we are only going to look at linear equations. First, let's consider two different equations. Equation 1, 3x plus 4 equals to 8. Equation 2, 3x plus 8 equals to 12. Let's see. Is there any relationship between equation 1 and 2? Maybe. But if we rewrite equation 2 as 3x plus 4 equals to 8 plus 4, we can see that the highlighted blue is actually from equation 1. What we have done here, to derive equation 2, we have added 4 on both sides of equation 1. Let's have a look at another example. Equation 1 is 4x plus 3 equals to 8. Equation 2 is 12x plus 9 equals to 24. Again, what is the relation between 1 and 2? If we rewrite equation 2, 3 times 4x plus 3 equals to 3 times 8. See, the blue bit is actually from equation 1. And equation 2 is actually derived from equation 1 by multiplying 3 to both sides of the equation. So, for any equation, if we add or subtract the same number from both sides of the equation, the new equation is equivalent to the original equation. Similarly, if we multiply or divide the same non-zero number to both sides of the equation, the new equation is equivalent to the original. Now you must know that equivalent equation has the same solutions as the original equation. Alright, time to solve some simple linear equation using equivalent equation. First, let's look at 3x plus 5 equals to 20. We can solve this by changing it to equivalent equation. First, from there, we subtract 5 from both sides of the equations. From there, we get the equivalent equation of 3x equals to 15. Then, we divide both sides by 3. And we can work out that x equals to 5. So this is one way of using equivalent equation to solve a linear equation. We have a few more examples to look at. This time, let's look at 3 minus 2x equals to 15. First, we subtract 3 from both sides. So, the equation we get is minus 2x equals to 12. So this is the equivalent equation to that one. Then we divide both sides by minus 2. Doing that, what we get is x equals to minus 6. So by manipulating this equation, first subtracting 3 from both sides, and then divide both sides by minus 2, we actually can solve that equation. Let's have a look at a different one. This time, it involves a fraction. Minus 2h equals to 4 over 3. First, we divide them by minus 2. So once we divide both sides by minus 2, we can find that h is minus 4 over 6 and is actually minus 2 over 3. Moving on to another example. let's look at 3 minus 4x equals to 15 plus 3x. In order to find the equivalent equation for this one, first we subtract 3x from both sides. Here, if we do a 3x minus 3x, that's 0, and 4x minus 3x, minus 4x minus 3x, that is minus 7x. So 3 minus 7x equals to 15. Then we subtract both sides by 3. What we get is minus 7x equals to 12. Then we divide both sides by minus 7, and we can solve it. X equals to minus 12 over 7. What I've done is shown you step by step how to solve it. The next few examples, I will be skipping all these steps. Alright, a slightly different example. This time, it involves a bracket. So we've got x plus 4 in the bracket multiplies by 3 equals to 9. First, we divide both sides by 3. So we have x plus 4 equals to, if 9 divided by 3, we've got 3. And then we subtract 4 from both sides. X therefore equals to minus 1. Do it another way. First, we expand the brackets. So we multiply the terms in the bracket by 3. So we have a 3x plus 12 equals to 9. And then subtract 12 from both sides, which means we have 3x equals to minus 3. And we divide both sides by 3, giving us x equals to 1. So both ways are acceptable. Two more examples involving brackets. First, the brackets are only on the left-hand side. We have 2 into x plus 1 plus 4 into x minus 3 equals to 26. Expanding the brackets, we've got 2x plus 2 plus 4x minus 12 equals to 26. Then again, working on the left-hand side, collecting like terms, 6x minus 10 equals to 26. 6x is 2x plus 4x. Minus 10 is 2 minus 12. Then we add 10 to both sides of the equation. We have 6x equals to 36, and therefore x equals to 6. How about this one? 2 into b plus 3 equals to 3 into b minus 2. Again, expand the brackets. This time, expand the brackets on both sides. So it's 2b plus 6 because it's 2 times b and 2 times 3. Alright? And 3b minus 6 because it's 3 times b and 3 times minus 2. Then we subtract 2b from both sides. We have 6 equals to b minus 6. Then we add 6 to both sides. We therefore have b equals to 12. Now, how about equations with fractions? 3x minus 1 over 4 equals to 4 over 5. How do we do this? Let's have a look at the fraction. What is the lowest common denominator for these two? It's actually 20. Therefore, we multiply both sides by 20. 20 into brackets 3x minus 1 quarter, and then 20 times 4 over 5. Alright, we therefore have 60x minus 5 equals to 16. Adding 5 on both sides, we have 60x equals to 21. And then dividing both sides by 60, we have x equals to 21 over 60. And simplifying it, we have 7 over 20. Another example, only one of them. It's a fraction. In this case, what we do is look at the common denominator, which is 4. So multiply both sides by 4. We have 40 minus a plus 3 equals to 24. Collecting like terms, 40 minus 3 is 37, and minus a, that's minus a, equals to 24. Therefore, a equals to 13. How about if we have fractions of both sides? The lowest common denominator is 12. Therefore, we multiply both sides by 12, which means what we have is 3 multiplies into a plus 5 and 4 multiplies into a plus 3. Expanding the bracket, 3a plus 15 equals 4a plus 12. Minus 3a from both sides. Therefore, we have 15 equals to a plus 12. And if we subtract 12 from both sides, we have a equals to 3. Last example, this time involves decimal places. We have e minus 1.8 equals to 2.9. How do we actually solve this? We can actually multiply both sides by 10, which means the equivalent equation is 10e minus 18 equals to 29. 10 minus multiplies by e is 10e. 1.8 multiplies by 10 give us 18. And 2.9 multiplies by 10 gave us 29. So, adding 18 to both sides, we have 10e equals to 47. Then, dividing both sides by 10, we have e equals to 47, and therefore e equals to 4.7. So, as a summary, linear equations can be solved by converting the equations into equivalent equations. To create an equivalent equation, any operation performed on one side of the equation must be carried out in the other side of the equation as well. So, if we add 2 on the left hand side, we add 2 on the right hand side as well. If we divide the right hand side by 4, we divide the left hand side by 4 as well. So for expression with fractions, we multiply all terms by the lowest common denominator. This is the end of the lesson. Thank you.